Displacement time graphs. How do they work? Well, let's take a look at this example. Here we have a displacement time graph, and here are 5 aspects of this journey. Work out the average velocity for each stage of the journey. Remember what we learnt about velocity. Velocity is speed in a given direction. Yeah? And speed is equal to distance over time, which means that the velocity is going to be the change in displacement over the change in time. So let's take a look at each of these examples. For part A, right, the velocity is going to be the change in distance over the change in time. Here you can see that it goes from 0 to 40, and it takes half an hour. So therefore the velocity, I'm underlining it because it's a vector, is going to be 80 kilometers per hour. Okay? Now let's look at part B. For part B, you can see that the velocity is going to be, goes from 40 to 60, and again it takes half an hour. So therefore, the speed at which it's going is 40 kilometers per hour. Yeah? Now, let's look at part C. For part C, you can see it's a flat line. So therefore, it is stationary. And the velocity is 0. Let's look at part D. For part D, we have a velocity going from 100 minus 60, because it goes from 60 here, and it ends up at 100, and it takes an hour. 40 kilometers per hour. And finally, part E, this time it's going negatively, which means it's going to have a negative velocity. This simply means that it's going back to where it started. It's going against the direction that we've modeled. So in this case, right, the velocity is going to be 0 minus 100. And how long does that take? It takes an hour and a half, so 3 over 2. And if you plug that into your calculator, you should get a velocity of 66.7 meters per second, kilometers per hour. Now, what's the average velocity going to be? Well, the average velocity, right, is going to be displacement over time. What is the displacement at 130? The displacement at 130 is 0, and it takes 4 hours. So the velocity is just going to be 0. Okay? What about the speed? The speed is the distance over time. Okay? And as you can see, it goes forward 100 kilometers, which means it has to go back 100 kilometers. So the velocity is going to be 200 divided by 4 hours, which is 50 kilometers per hour. And that is your final answer. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's take a look at this question. Khalid drives from his home to a hotel. He drives for 2.5 hours at an average velocity of 60 kilometers per hour. He then stops for lunch before continuing on. After 30 minutes, he drives again for another 60 miles per hour. I added that bit because I wanted you to draw the diagram first and work out the displacement from the hotel. So, This will be the displacement, or S, and this will be the time t, okay? As you can see, he drives at 60 miles an hour, which means this gradient is 60 kilometers per hour. And down here is 2.5. How are we going to work out this S? Well, this S, what do we know? Velocity is equal to change in displacement over change in time, which means that 60 miles per hour, kilometers per hour, is equal to S divided by 2.5, which means that S is equal to 2.5 times 60, which is equal to 150 kilometers. And so we can say this is 150. Right, let's carry on drawing the graph. Here, we're going to stop for 30 minutes. So from here to here is 3 hours. And then he drives again for an hour at 60 kilometers per hour, okay? So this here is going to be 4 hours, okay? Now, the question is what is his average velocity? We know that he's only going in one direction, so we don't need to worry too much about the directions, okay? What's his final displacement at? Well, S is going to be, this will be the change in distance is equal to velocity over time. And because it's only an hour, and we know this is 60, this is going to be, velocity times time, right? And S is going to be 60 times 1, which is 60 meters. So therefore, S is going to be 210 kilometers away from his house. Yeah? So this is 210. So the question is how long does it take on average to get there? Or what speed is it? The average speed or average velocity is going to be 210 divided by 4. It's the total distance traveled and the total time traveled. So if you plug in 210 over 4 into your calculator, you should get an answer of 52.5 kilometers per hour. And that is your final answer. Do you still need more help? Well, join my Discord server and ask me whatever questions you want down below for fast responses. Now let's take a look at this question. Sarah left her home at 10 o'clock and cycled north in a straight line. The diagram shows the displacement time graph for her journey. Work out Sarah's velocity between 10 and 11. Well, between 10 and 11, what's the gradient? So the velocity, I'm just going to say the velocity is going to be the change in displacement over the change in time, which is 12 minus 0 over, and it takes her 1 hour. So therefore she moves 12 kilometers per hour. Okay? On her return home, right, she passed her home and, she made a pit stop or something. Estimate the time that Sarah passed her home for. So all we're looking at here is just the time at which she is away from her home here. Okay? So to do that, all we need to do is measure this time taken. I'm going to delete this part just so I can see it. I'll estimate that this is halfway through, so this is 12:45. I'm also going to estimate that this is at 2 o'clock. Okay? So how long was she there? The time taken there is just going to be 75 minutes. Or an hour 15. Either one. Work out the Sarah's velocity for the last two stages. The last two stages, so I'm going to call this one B and this one C, right? For B, right, V is going to be, again, the change in displacement over the change in time. She takes, how long is that? That is an hour and a half, right? So it's all divided by 1.5. Now, let's take a look at her displacement. That looks like -3 to me. And she starts at 12. So it's going to be -3 minus 12. So it's going to be -15, right? Over 1.5, which is 10 minus 10 meters per second, kilometers per hour. If I'm saying meters per second, it's just muscle memory. Okay? Now, part C. Here she's going towards her home, or rather, she's going away from her home. Like, she's going in the direction, like in the right direction. Okay. Sorry, that was a mistake. So her velocity is going to be -3. No. 0 minus -3. Right? Over, and how long does that take? That looks like it takes an hour. So that velocity is 3 kilometers per hour. All right? What's her average speed going to be? Her average speed is going to be the total time that she takes. And you're going to use that to divide the total distance that she takes. Here, she goes 12, right? Which means she has to go back 12. Here, she goes down 3, which means she needs to go back up 3. So her total, her total distance is going to be 12 plus 12 plus 3 plus 3, which is going to be 30 kilometers. Long journey, long journey. How long did it take? It took 4 hours. So her average speed is going to be 30 over 4, which is equal to 7.5 kilometers per hour. And that is your final answer. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colours? Well, you can get tutored by me. Drop me an email for a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.